Hello everyone, welcome to another technical deep dive. My name is Cody, and in this episode we're going to provide an overview of zones and show you how you can create and manage them in the DeepHub. A zone describes an area of transformation that applies to real-time locating systems such as ultra-wideband or Wi-Fi, proximity-based systems such as RFID, and custom areas of measurement. Within this area, local coordinates from a locating system are transformed into geographic coordinates. A zone pertains to the low-level hardware and infrastructure associated with locating systems. It is the common denominator between different locating technologies and enables standardized processing of location data according to its configuration. Zones only need to be created once during the administration, installation, and setup of your system with the DeepHub. If a location provider moves within the boundaries of a zone, it communicates with its corresponding infrastructure, the local coordinate gets transformed into a geographic coordinate, and the position of the location provider updates in the DeepHub. If you have the DeepHub already installed, you may work with zones through the REST API or the UI. Check out one of our previous episodes if you need to install the DeepHub. There's a link in the video description down below. Let's begin by exploring the UI. In the admin UI, we can create new zones and edit or delete existing zones. To create a new zone, first click Create Entities, and then Zone. An ID will be automatically generated, and you'll have the ability to add other information associated with it, such as its name, foreign identifier, floor, and custom properties as metadata. You will also need to select the location technology type and a method to define the zone. For zones associated with real-time locating systems, including ultra-wideband, Bluetooth Low Energy Angle of Arrival, Bluetooth Low Energy Mesh, and Wi-Fi, there are three methods of defining a zone. The first is an extent-based geometry. Here you can define the height and width of a rectangle in meters and have the option to provide a rotation value. You may define the centroid of the rectangle by providing longitude and latitude coordinates, or by clicking the blue Locate button and then clicking on the map. The next method is done by providing local coordinates in meters for each corner of a polygonal zone and an optional rotation value. The polygon must have a minimum of 4 points. You can georeference the origin point of the polygon by providing longitude and latitude coordinates, or by clicking the blue Locate button and then clicking on the map. By default, the first point is used as the origin of the zone. However, by turning on Advanced mode, you may set a custom origin point in meters. The final method of creating an RTLS zone is by drawing it on the map or by providing geographic and local coordinates. To draw the zone, simply click the blue Locate button and then click on the map to draw the zone. To finish drawing a zone, simply left-click on the first point you created. Once that's done, you will need to enter the local coordinates in meters associated with each point of the zone. Typically, point 1 corresponds with the origin point of the local coordinate system. For proximity-based systems, including iBeacon and RFID, you can create a zone by simply drawing it on the map or by providing geographic coordinates in the form of longitude and latitude. Just like before, click the blue Locate button and then click on the map. You can also set the radius of the zone in meters. As we can see, zones are differentiated by color. RTLS zones are all green, and proximity zones are all orange. Now that we've got our zones created, we can edit them directly within the UI. We can either search for a specific zone or get a list of all zones by clicking the button at the top of the screen. To begin editing, I'll click the Edit button. With this zone, I'll adjust the height, width, rotation, and centroid until the zone is perfectly in place. Edits are visualized in real time, making it very easy and intuitive to adjust zones according to your requirements. Once I'm finished, I'll hit Update. And that's it. With just a few clicks and configurations within the UI, our zones are set up and ready to begin transforming location data. But we're not just limited to the UI. The DeepHub REST API has several endpoints that may be used to manipulate zones within a DeepHub instance. With these endpoints, you can create, delete, and update zones, retrieve information associated with zones, and perform other advanced spatial functions. The post zones endpoint may be used to create a new zone. This is the only creation mode available via the REST API. It corresponds to the drawing on map creation mode in the UI that we explored earlier. In the request body, the type field is required. This defines the technology type associated with the zone, such as ultra-wideband, BLE mesh, RFID, etc. Other fields may be included as well, depending on the type of zone you'd like to create. Some are integral for the configuration of the zone, such as position, ground control points, and transformation type. Others are used to add metadata to the zone, such as a name and a description. Just like in the UI, you can add custom properties as well. For detailed explanations of all available fields, refer to our documentation linked in the video description. A 201 response indicates the request was successful, and we can see the newly created zone in the UI. The put zones zone ID endpoint may be used to update a specific zone by providing its zone ID. In the body of the request, we can update a few of its properties. A 200 OK response indicates the request was successful, and we can see that the zone has been updated as well in the UI. Finally, we may use the delete zones endpoint to delete all zones, or the delete zones zone ID endpoint to delete a specific zone by specifying a valid zone ID. A 204 response indicates the request was successful, and we can see that the zone has been deleted in the UI. This was an overview of zones in the DeepHub. Please like and share this video if you found it helpful, and subscribe to our channel for more future DeepHub content.